Welcome to everything that is, was, or will ever become. Some background on this image. This image is our Earth at the end of the arrow. Taken from Voyager 1 in 1990, looking backward as it leaves our solar system. It is taken from 4 billion miles away and is pure luck that it was in the frame at all. It's a pale blue dot, less than 1 pixel in the photograph. Welcome to the universe, people, and where we fit into it. And what better way to introduce our unit on astronomy than one of the most amazing astrophysicists of our time, Carl Sagan. So, without further ado, I would like to have Carl Sagan take it from here.
From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering. Thousands of confident religions, ideologies, and economic doctrines. Every hunter and forager, every hero and coward, every creator and destroyer of civilization. Every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the only home we've ever known, the pale blue dot.
Okay, I don't know about you guys, but that one makes me feel very, very small. Love that line. Momentary masters of a fraction of a dot. So, welcome to astronomy. Yes, and this one is huge. Everything that is, was, or will ever become. So, without further ado, let's dive into this. Okay, thanks again, Carl. Dude's a rock star. One of my favorite space dudes. All right, so how did this whole thing start, anyway? All right, no one knows for sure. Yay, science! Unanswered questions. All right, but there are lots of theories. So the most commonly adopted and used is the Big Bang theory. Here, check this out.
As our nebula began to collapse under its own gravity and spin faster, a dense clump of matter formed in the center. It's called a protostar. At first, its heat was due to friction, but when the clump reached 18 million degrees Fahrenheit, nuclear fusion kicked in. 4.5 billion years ago, our star was born. Hydrogen atoms fuse together to form helium, and in the process, release photons. It's the first light made by our sun, and it will keep on shining for 4 billion years. A vast nuclear furnace nearly 1 million miles across. From a distance, this process seems almost peaceful, with the sun's power gently radiating out into the early solar system.
There was all sorts of activity going on. Things were changing rapidly, violence, explosions, intense radiation. We had a pretty spectacular origin, I think.
Recent research suggests the solar system's birth was far from peaceful. Our sun may in fact have been born out of one of the most violent events in the cosmos: the explosive death of another star. And even before that, it seems there was an explosion so huge that it created an entire universe. The Big Bang. No one knows what caused it, but we think that the bang created space, time, and all the matter in the universe. Yet for astrophysicists, such as Professor Stan Woosley, there's a puzzle. The Big Bang produced almost none of the 88 naturally occurring chemical elements.
When we look around, we don't just see hydrogen and helium. We see planets and people, and we're made out of carbon and oxygen, and planets are made out of iron and silicon. And that didn't all come from the Big Bang. It had to come from somewhere else.
Here on Earth, we have learned how to create new elements for ourselves. Nuclear technology. The same thing happens inside stars. Hydrogen and helium from the Big Bang fuse to form heavier elements. And if the star is big enough, at the end of its life, it does something spectacular. It explodes.
The energy of a supernova explosion is essentially equal to all of the energy that the sun will put out in its 10 billion year lifetime.
All right, so the Big Bang Theory. It's about 10 to 20 billion years ago. All matter and radiation was compressed to form a hot, dense mass just a few millimeters across. All right, this lasted for a fraction of a second before it all exploded with immeasurable speed. This explosion created time, space, everything we know. That's a mind blower. This one explosion created everything, including time, which is in itself an amazing concept, and everything else we knew. All right, Big Bang. It was first theorized in 1920 by George Lemaitre. This guy was a Belgian priest. All right, the theory later was given boost by Edwin Hubble's observations. Edwin Hubble, you might recognize that name. The Hubble Space Telescope was named after him. His observations that galaxies are speeding away from us in all directions. So it's the theory of the expanding universe, that all galaxies are moving outward. Cosmic radiation. This is another interesting thing. So cosmic microwave radiation. This is similar to the radiation used to transmit TV signals. It's our oldest form of radiation, and it's found throughout the universe. So this type of energy may be evidence of the Big Bang Theory because it's found everywhere in our universe, and it might be a remnant of the Big Bang. So here are my wonders. All right, so if you had the Big Bang right here, what if you rewind to what happened before the Big Bang? I mean, what energy was right there? And the big one is, the Big Bang is what caused the compression of all that energy. So what was acting on the outside, what was acting on that energy that moved it all into that one or couple of millimeter space that caused that final explosion. I love that stuff, because I mean, what existed before existence? What existed before existence? Love it. Love astronomy. All right, here we go. Bring it. Nobody knows for sure. Here we go.